Hello students. Welcome to MH Tutorial English. In this animation video, we are going to learn how Ohm's law is derived from the atomic level. After watching this entire video, you will be able to answer all these questions yourself. Any metallic conducting wire consists of a huge number of atoms or molecules arranged in almost in an homogeneous distribution. Each atom may contain one or two or three conducting electrons. Conducting electrons are found rotating along the uppermost orbit of a metallic atom. These electrons are loosely bound to the atom. Therefore, they can leave their parent atom easily and start roaming. This is why they are called free electrons. When an electric current flows through a conducting wire, all those atoms do not move anyway. These free electrons move and carry charges from one end to another. Remember, electric signal moves at a velocity equal to that of light in free space. But electrons never reach that limit. Speed of electrons depends on the value of the applied voltage difference. In a current-carrying wire, if suppose 5 electrons enter the starting point, to maintain equilibrium condition, 5 electrons should emit from the end point. But these emitted electrons are not the same that entered. Now, let us calculate the resistance of this segment of the wire. In an electric field, electrically charged particles should move at an accelerated speed. But collisions against the standing atoms modify its speed. This makes its speed not accelerated, but an almost steady speed. It is called drift velocity. If we track a single electron, its path or trajectory would have looked like this. You can understand that the trajectory is not linear. It is a curve. Between two successive collisions, the electron moves at an accelerated speed. Here, the thicker areas indicate points of collisions, and thinner areas showing the runways of the electron. Distance between two successive collisions is called a free path. Electron moves accelerated throughout the free path. Let voltage difference between two ends be V. Then electric field between them will be V by L. L is the length of the wire segment. Force acting on an electron is A V by L, where A is charge of an electron. Therefore, acceleration of the electron is force by mass, or A V by mL. Here m is the mass of an electron. Inside the wire, an electron undergoes random collisions against the atoms. Suppose tau be the average duration between two consecutive collisions. In this small interval of time, an electron gets acceleration and manages to travel a finite distance. Let this distance be s. Using s equal ut plus half a t square formula, we get s equals to half a v tau square by ml. Therefore, average velocity or drift velocity of an electron is s by tau, or vd equal to a v tau by 2 ml. During an interval of delta t, total number of electrons that pass through this plane are equal to the number of electrons inside the cylinder of length Vd into delta t. That is the number of electrons inside the volume Vd into delta t into A into N, where A is the cross-section area of the cylindrical wire, and N is the density of electrons inside the matter, or number of electrons per unit volume of the wire. Thus, we get total charge I into delta T equal to Vd into delta T into A into N into A, where A is the charge of an electron. Substituting the expression for Vd, we get I delta T equals A V tau delta T A N A by 2 ml. Or I delta T equals Na square V A tau delta T by 2 ml. Or V equal to bracket 2m by Na square tau bracket closed L by A into I. This is Ohm's law expressed in mathematical form. Thus Ohm's law is stated like this. Current flowing through a conducting wire is proportional to the voltage difference across it if the physical properties of the wire remain unchanged. Electrical resistance is defined to be the ratio of the voltage difference and the current. This equation gives the expression for resistance as bracket 2m by Na square tau bracket closed L by A. Thus resistance is proportional to the length and inversely proportional to the cross-sectional area of the wire. Electrical resistance is measured in ohm. If the applied voltage across a wire be 1 volt and current flowing through it be 1 ampere, then its resistance is 1 volt by 1 ampere. Or simply 1 ohm. The expression inside the bracket is called the resistivity of the material of the wire, and symbolizes with Greek alphabet rho. Or resistivity rho equals to 2m by Na square tau. Resistivity is a property of the matter. In SI system, resistivity is measured in ohm meter. Hope you understand Ohm's law. See you in our next video. Thanks for watching the video till the end.